What is going on, guys? Welcome back to my channel, and today we're going to talk about HashGraph. Many of you have requested for me to cover HashGraph on this channel, and that is for a very good reason, because HashGraph, they have gotten a lot of attention recently. They claim to be very fast and be able to handle over 250,000 transactions per second. They claim to be secure, and they also claim to be fair. And we're going to talk more about what fair means in this context of distributed ledgers and blockchain technology, but in this case it's not even a blockchain. And guys, before we start, I want to remind you that if you go to academy.ivanontech.com, you can enroll in my online course where you learn all about Bitcoin, how that works under the hood. You learn how Ethereum works under the hood. You learn about the industrial use cases of the blockchain technology. You learn about mining. You learn about different consensus algorithms, you learn about hash functions, you learn about public key cryptography, you learn about ICOs, and so on and so forth. So if you're interested, check out academy.ivanontech.com. The course will be launching on February the 1st, but if you enroll before February the 1st, if you buy it on pre-sale, you'll get more than 50% off. And that being said, guys, let's get into it. So HashGraph is a new way of reaching consensus in a decentralized network. First of all, we have to understand the difference between voting algorithms and algorithms such as proof of work and proof of stake. Because let me just adjust the focus. Because HashGraph, they really want to be a voting algorithm. If you look at their talks, if you look at their presentations, they want to be a voting algorithm. And so let's just talk about proof of work and proof of stake really quickly. In proof of work, we have miners who mine the next block. They spend electricity, they spend computational resources, and the advantage is, of course, that it is extremely secure. And the computational power securing the network is often enormous. In proof of stake, we have the following situation, that you and I will lock up funds, and these funds are locked up, and we vote for the next block. And if we vote incorrectly, if we try to get some malicious block into the blockchain, some malicious transactions into the blockchain, we will lose our stake that we have locked up. While in proof of work, the disadvantage is the performance, because we need to wait for miners to find the next block, then we need to propagate the block through the blockchain so that all nodes know about this new block. And another disadvantage is that your transaction will be handled synchronously. Your transaction will be put in the mempool, and it will wait in the mempool together with a bunch of other transactions before it gets put into the block together with other transactions, and then it will be put into the blockchain together with a bunch of other transactions. So we have this batching going on. And the whole idea with the voting algorithm is that we have our different nodes in the network, and they all tell each other what they think happened. So for example, we might have the following situation, that we have a couple of nodes here, and now these three nodes, they need to decide on whether a transaction is valid or not. So all of them will just tell each other what they think. And as you can see, this system is extremely decentralized. There is no way to somehow centralize this setup. While in proof of work, for example, we can centralize miners, because miners have the consensus function. They do the consensus while the users are not involved in the consensus. So we have some centralization possibilities in proof of work, while if we have a voting algorithm, it is completely decentralized. And this also means that transactions will be handled asynchronously, that as soon as we have a transaction, it doesn't have to wait for a bunch of other transactions, and then they together will be handled. However, the issue is, of course, bandwidth. If I have to tell each and every other node what I think, and I have to do that for every transaction, it quickly becomes unviable. It quickly becomes too heavy on the bandwidth. And so voting algorithms are very good in theory. In theory, this is secure, this is fast, and in practice it is impossible, because it is just so many messages we need to send, and therefore voting algorithms are not possible practically. However, HashGraph, they really want to be a voting algorithm, because they see this potential and this advantage of voting And so they try to build this data structure HashGraph in such a way that it has all of the advantages of voting algorithms without this bandwidth disadvantage. So how do they do that? Well, they developed something called a gossip protocol, meaning that if I'm a node in the network, let's say that I'm a node right here, and I get some information, I will randomly pick another node and tell them everything I know. Now this node will pick another node and tell them everything they know. And then I will pick some other node and tell everything I know again maybe. And so everyone is just randomly picking a neighbor and telling them everything they know. This means that eventually all the nodes in the network will get the information. Because if everyone just picks a random neighbor telling them everything they know, mathematically this will converge and the information will spread. And when we tell each other everything we know, we're not only talking about what happened. So it's not only that we tell them about the transactions, for example. We also talk about who told me what I now tell you. So it is not only what, it is also who, and it is also when. So we have this time aspect. And this is something that proof of work and proof of stake lack. Namely, they lack fairness. We mentioned fairness in the introduction, but there is no fairness in these systems. What do we mean by that? Well, it means that the order of transactions is not guaranteed in proof of work and proof of stake. The miners will decide what transactions they want to include in proof of work, for example. And it is mostly based on transaction fees. But the miners decide what they pick and they can alter the order of transactions. While when we have this when time aspect in the gossip protocol, we actually guarantee fairness. So HashGraph, they claim that they guarantee fairness and ordering of transactions. And so when we have this situation going on that everyone is just telling neighbors what they know, everything they know, they also include information who told me what I know, when it happened, and what did I learn. When we have this setup, we can do something called virtual voting. And this is very interesting because here we have voting in a way where everybody is telling everyone what they are voting for. While in virtual voting, we don't tell each other. Because if I know everything you know, because you just told me everything you know, I can deduce your vote. Because I have your worldview. I know exactly what you're going to vote for without you telling me. And so in this structure, in this system, the nodes only tell random neighbors and we don't tell everyone at once. But because the information spreads, because we have this convergence of information, sooner or later everyone will have the entire set of information that is on the network. And this is how they claim to have 250,000 transactions per second and how they want to make the protocol fair, because we have this time aspect. And so, is this all only positive? Well, of course not. It is never all positive. Because something that we have to keep in mind is that this technology is patented. And in order to use it, for example, if you go to their website and you try to program with this technology, with this code, you actually have to request an SDK from their company. And an SDK is basically software development kit, which you use in order to develop applications that are not open source. Or maybe you can have SDKs for open source software as well, but if you have closed source software, then you definitely need an SDK. And of course, I'm not judging here because it is their company, they created this technology, so they can do whatever they want and however they want. But of course, the nature of cryptocurrencies, the nature of this space that we are in this crypto space, it is open source, it is having the code online so that everyone can check, everyone can make sure that it works, everyone is certain that it has all the features that we just talked about. However, something we could think about is that this whole technology, it may very well be the case that they are targeting industry, that this is a product for huge corporations that want to use this technology and want to pay the HashGraph company, Swirls, as it's called, for this technology. And it may be the case that it isn't intended to be open and permissionless, such as Bitcoin. We still have to see. I mean, it is in this sense, it is a lot of mystery, and I'm not a patent lawyer, so I'm not completely sure exactly what the situation is with this patent and whether it can be used in the same way as Ethereum, for example, or as Bitcoin. When it comes to that, you and I, we can just take the code and we can fork and we can create our own network based upon this source code. So in that sense, this is still something that we need to be asking ourselves. Another point, community. So HashGraph, they have gotten a lot of attention, but the actual community, the actual development community, all of the fans, this is something that HashGraph still needs to work on a lot. And so in that sense, it is extremely interesting. I think that they have some good promises here with virtual voting. However, we still have to see this on a public live network, and we still have to follow these developments, and it is way too early to say that HashGraph is going to replace all blockchains, for example, as they claim sometimes. It is still way too early. But guys, this is the overview you need to have in order to understand this. This is how you need to think about this, that this is voting versus proof of work and proof of stake and other consensus algorithms, and they want to do virtual voting, and there are these issues with patent that you need to request an SDK, and might very well be the case that it is for the industry. So guys, thank you so much for watching. Smash the like button, the bell button, and subscribe if you are a new viewer, because you will find this channel interesting. I'm a software developer, and I'll see you guys next time.